Imagine designing a fighter jet so extreme that its own engines couldn't even start it. Not because the engineers failed, not because the blueprints were wrong, but because the technology they were building around simply didn't exist yet in any form that could be trusted with a human life. And the only solution anyone could propose was strapping a rocket to the bottom of the fuselage and hoping the pilots survived the handoff. This was Germany in 1944. And what a small team of engineers at Focke-Wulf quietly began drawing on paper would remain one of the strangest and most forgotten weapons concepts of the entire war. The project was called the Ta 283. Almost nobody has heard of it because it never flew, never reached a runway, never made it to a wind tunnel, never had a single engine test-fired in the configuration the aircraft required. But the ideas inside it were so far ahead of everything else being built at the time that they would quietly surface again in aerospace programs across the world for decades afterward. And the story of why it failed reveals something deeply uncomfortable about how far ahead certain minds were working while the world collapsed around them. By 1944, Germany was losing. Not slowly, not ambiguously. Everyone inside the Luftwaffe understood the situation clearly, even if nobody said it openly. Allied bombers were hitting German factories around the clock, day and night without pause. Cities were burning. Production lines were being dismantled from the air before they could finish building the weapons Germany desperately needed. Experienced pilots were dying faster than new ones could complete training, and the aircraft that once given Germany air superiority over most of Europe were no longer enough to stop what was coming. That pressure pushed German engineers into dangerous territory. The Messerschmitt Me-262 had already shocked the Allied world by introducing jet propulsion to actual combat operations. Pilots who encountered it reported something that felt almost unfair. The aircraft was simply in a different category of speed. The rocket-powered Me-163 Comet went even further, hitting velocities that almost no Allied fighter could match in level flight. To the outside world, Germany's experimental aviation programs looked like a continuous stream of terrifying innovation. But inside Focke-Wulf, chief designer Kurt Tank believed even those machines were already becoming outdated. Tank wasn't a minor figure. He was the man behind the FW-190, one of the most dangerous and effective piston engine fighters Germany produced during the entire war. When the FW-190 first appeared over the English Channel in 1941, it outperformed the Spitfire Mark V so badly that British commanders were forced to ground their pilots until newer variants could be rushed into service. Tank's instincts for performance were not theoretical, they were proven in combat. And in 1944, those instincts told him that the future of high-speed flight didn't belong to turbojets at all. It belonged to ramjets. At first, the logic behind that conviction seemed almost elegant. Traditional jet engines were extraordinarily complicated machines. Turbines, compressors, precision-machined rotating components, exotic heat-resistant materials that Germany was already struggling to source late in the war. Every month, those supply problems worsened. Factories were being bombed, skilled workers were being conscripted, the precision manufacturing that advanced jet engines demanded was becoming harder to sustain with every passing week. A ramjet eliminated almost all of that complexity. No compressor, no turbine blades, no massive rotating mechanical systems. The aircraft's own forward velocity would force air into the engine intake, where fuel would ignite and generate thrust. The physics were straightforward. The faster the aircraft flew, the more efficiently the engine performed. In theory, a well-designed ramjet could push an aircraft to speeds that a conventional turbojet could never reach, using a fraction of the moving parts. It sounded like the answer to every problem Germany was facing, except for one flaw so fundamental it should have stopped the entire concept in its tracks. A ramjet produces almost no usable thrust at low speed. The engine couldn't move the aircraft from a standstill, couldn't taxi it down the runway, couldn't even begin to function properly until the aircraft was already traveling at extremely high velocity. The engine that promised extraordinary performance at altitude was completely helpless at the exact moment a pilot needed power most, taking off, climbing, accelerating from nothing. Most engineers who understood this looked at ramjet propulsion from manned combat aircraft and concluded it was a dead end. The launch problem alone seemed impossible to solve practically. Kurt Tank didn't walk away. He'd been following experimental ramjet research being conducted by Dr. Otto Popst, who genuinely believed the technology could eventually power high-speed combat aircraft if the launch problem could be solved through other means. The concept fascinated Tank, precisely because the obstacles felt like engineering problems rather than physical impossibilities. And Tank had a habit of solving engineering problems that others had already given up on. To develop the aerodynamics, he brought in Hans Multop, one of the most forward-thinking aircraft designers in Germany at the time. Multop approached the shape of an aircraft differently from most engineers of his era. He didn't think about engines and weapons first and then build a body around them. He treated the entire aircraft as a single aerodynamic equation that needed to be solved with absolute efficiency. Every surface, every angle, every curve existed to reduce drag and maximize control at extreme speed. And the solution they began developing together looked unlike almost anything else proposed during the entire war. The Ta 283 was compact, narrow, and aggressively streamlined. Its wings swept sharply backward at approximately 45 degrees, an angle considered extremely radical for the mid-1940s when most combat aircraft still flew with relatively straight or only slightly swept wing configurations. The fuselage was dart-shaped and narrow. The cockpit sat unusually far toward the rear of the aircraft, tucked beneath a tall, vertical tail that gave the design an almost alien silhouette from certain angles. Visibility behind the pilot would have been poor, but the Ta 283 wasn't designed for turning dogfights that required situational awareness in all directions. Its intended mission was specific and brutally simple. Climb fast, reach bomber formations before escorts could intercept, fire a short, devastating burst from its two heavy 30mm cannons, then accelerate out of range before anyone could react. It was designed less like a fighter and more like a guided projectile with a pilot inside. But the strangest feature of the entire aircraft wasn't the swept wings or the dart fuselage or even the cramped cockpit position. It was where the engines were mounted. Instead of placing the ramjet pods under the wings or inside the fuselage in the way almost every jet aircraft before and since has organized its propulsion, the Ta 283 mounted its enormous ramjet engines at the very tips of the horizontal tailplane. Two massive pods, each almost wider than portions of the fuselage itself, extending outward from the tailplane like something designed by someone who had completely abandoned conventional thinking. It looked, by any normal standard, completely insane. But there was precise reasoning behind it. Mounting engines that large anywhere near the wings would have created catastrophic aerodynamic interference, disrupting airflow across the surfaces that the aircraft depended on for lift and control. Pushing them all the way back to the tailplane tips kept the wings clean and theoretically maintained stability during high-speed flight. The arrangement had never been tried on a combat aircraft before. Then again, almost nothing about the Ta 283 had ever been tried before. And none of it addressed the launch problem that remained at the center of everything. So the engineers arrived at the solution that still seems barely credible when you read it today. A Walter rocket motor mounted beneath the aircraft, the same brutal propulsion technology that had been used to hurl the Me-163 Comet into the sky at terrifying speed. Except on the Me-163, the rocket was the primary engine. On the Ta 283, it was just the starting mechanism. The rocket's entire purpose was to accelerate the aircraft fast enough for the ramjets to ignite and take over. At takeoff, the rocket would fire. The Ta 283 would surge down the runway with enormous force, pressing the pilot back into his seat with acceleration that left no margin for hesitation or error. Once airborne and climbing, the pilot had a narrow window to reach the exact airspeed at which the ramjets could sustain combustion on their own. The rocket fuel supply lasted approximately 30 seconds. That was the entire margin between a successful mission and a silent, powerless descent with no engine response and no recovery option. 30 seconds to launch, accelerate, reach critical speed, and successfully transfer propulsion from one system to a completely different one that had never been proven reliable in any real-world test. Imagine being the pilot strapped into that aircraft. One moment you're riding a rocket at accelerations that compress your body into the seat. The next moment, if the ramjets failed to ignite cleanly, you're a glider,
falling with dead engines behind you and nowhere to go. And yet, despite all of that, the performance projections that came back from the calculations were staggering. German engineers estimated the Ta 283 could reach speeds approaching 1,100 kilometers per hour at high altitude. For context, the Me-262, which had already been described by Allied pilots as something from the future, flew considerably slower. The Ta 283, on paper, wasn't just faster than anything Germany had built, it was faster than almost anything any nation would put into operational service for years.